Alright, hi there. I'm going to discuss one of the file formats we find in Resident Evil 4 Ultimate HD Edition for the PC, which is the RPT file. Now, this is the Resident Evil 4 Trial Edition for the GameCube, which I believe .cal and Mark Grass modded to allow for the debug menu to pop up. I think there's another ROM floating around the internet that has the debug, but I can't find it. So if anybody has that, could you just please contact me, because I would like to see if it's more functional than the one that .cal Mark Grass released, because the debug functions in here just don't work. There's a few functions that do, but many don't. Alright, so in this version we can press like the trigger and the start button, and it brings up the menu here. Now we have to be careful, because if we click on something, it could crash or something or whatever. But this does work here, the flag edit, and we have certain toggles that change minor things in the game. There is one here which will enable display to show what the RTP file does. So that's how I'm able to visualize it. So I'm going to get out of here. And with this enabled, we can see the different pathways of what the RTP file does, how it works. So we're given a node, which is one of these like pylons. Okay, it has a number on it, and then it has a path that you can follow. Okay. Its exact involvement, how the game runs, is not quite clear to me yet, but I would imagine if there's an enemy who's patrolling, they would just follow this pathway for that routine. I do know when you get spotted by enemy, they just beeline it, they'll bump into walls and run towards you, so I'm not exactly sure what exactly this file does. But I'm trying to break down the data, and so this representation really works well, because there's not too many. There's about 10 of these, and the room is so small that we can gather the points and the shape of this pathway. Alright, so yeah, so I wrote down these numbers, and just roughly drew a diagram, and I drew the path connection on an image. So I'll just jump out of here. Don't need that. Here's the image that I I drew up. So this is where we spawned, and I walked around to the areas of the map, and I was going from node to node. But this is the first node, and it was called 0, and then it extended over to, the game uses hex, it would have called it OA, like that, but I just call it 10 in decimal. Okay, so now we have these pathways. So when we analyze the file, we can understand the pathways. So I'm going to walk you through the file, explain that. So I have this color blocked out, and I'm going to explain each block of the file. So the first 4 bytes here is what we call a 4-character code identifier, a 4CC. It's a unique number that should describe the file format, like an extension, right? So it's a PTR, or rather an RTP file. Maybe the 2 stands for its version, I don't know. After that, we have 2 bytes. I don't think it has any meaning. I think they just added the 2 bytes there. Maybe it was for something else. After that, the 2 bytes is the count for the first table. So this in green is the first table. The second count is for the second table, which is this one here, pink. And then the third count here is, sorry, the 79, is the size of the last table, not the count. And then we have the 3 addresses. So we have, this is the address of table 1, this is the address of table 2, and this is the address to table 3. Okay, these are pointers. They point to the spot in the file where you can find the data. All right. So now we analyze the tables. This is the first table. The way it works is it defines in 4 bytes the X position, another 4 bytes the Y position, another 4 bytes the Z position. Okay, so it's X, Y, Z, or I don't know, Mr. Curious was saying like the game does X, Z, or Y, or backwards or something. But anyway, for whatever reason, it doesn't matter. It's just this is your three components of your position. And then after that, we have 2 bytes. That is the index to the second table. And then the second byte here, the 2 bytes, is the count. So this is saying we're going to position 0 in the table 2. So this is position 0. And we're reading one element from the table. So in this table, it's 4 bytes per entry. So this is just one entry. So at position, we'd read this. Okay. And then the second entry, which is this one, again, we have X, Y, Z. Then we have 1. So position 1 would be here. And we're reading 2. So it would be 1, 2. Okay. This one, the third entry here, which is this one. Again, X, Y, Z. Then we have 3, so that's position 3, read 2. So it's going to be 0, 1, 2, 3. So we're going to read 1, 2. That's how that works. Okay. So the second table, that goes without saying, it's just the 4 bytes, but what it is 2 bytes is the connection from here. So that's saying that we're going to draw a connection to 1. So this is position 0, so that's 0. And 1 would be the second entry. Okay. And I'll explain how that ties in together. And then the second 2 bytes in that table is the length of the segment. And then this one's kind of complicated, so I'll have to illustrate how that works after. So first let's walk through this on our picture, and we can see how that's drawn. So let me switch to a different color here and walk that through. All right, so first entry here, okay, it's defining our first node, and that would be this one. Okay, we plot it out, and then it's telling us that we need to read the other table at position 0. So that would be here, and that would be what we read. And the 2 pieces of information we're supplied is 1 and the length. So this is telling us is that from here we need to draw a segment to 1, and it needs to be whatever length across that's specified here. It's worth noting that the length is it's reduced by a factor of 10. So if you want to get the true length, you have to times this number by 10 to be correct. But it doesn't really matter. It's when we're rewriting the file, it's important to know that so we can get the correct sizes. But I notice that this is off by a factor of 10. Anyway, let's follow the next entry, and I'll use a different color. Say pink. And so the second entry we have here is saying that we go to entry, so we go to the table 2 at position 1, which is the second entry, and then we read twice. So we go 1, 2. So let's break that down. It's saying 0, and we're just going to skip the length, and then 2, and the other length. So this is saying is we are now at, okay, node 1, which is the second one, and we need to draw a connection towards 0 and 2. So we draw 1 to 0, and then 1 to 2. All right, and that draws our segments. And following this principle, you just work your way down the list, and you end up building all the segments across all the nodes. Okay. Now let me illustrate what this does. Basically, what it does is it tells you the children. So what are children? I think that needs to be explained. Basically, we have a thing. Let's just call it a thing, okay? And there are other things attached to it, all right? And we can call this a number of things, a tree, a hierarchy, a whole bunch of things. But when I'm referring to a child, let's say this is our primary object. It's when we say children, it has a relationship to other things. So this object would be dependent on this one, and this object would be dependent on this one. An example of that is in 3ds Max we can assign what we call parenting or linking. So I'll demonstrate that. We can use the linking tool to connect these two to our primary object, which we'll say is this one. And we can represent these connections in 3ds Max as well by showing their links. So we can see that this primary object is these as children, and when we move them, the childs are moved with that as well. Okay. As you move the children, they move independently, but if you move the root object or parent object, their children are affected. So that's the concept of children. So when we're talking about representing childs, okay, we need to know the index of each block, and we need to say, okay, well, 0 has the child 1. So that's all we have to indicate. But what they do in the file is interesting, and I don't understand the full extent of it, or the reason of it. But basically, for each node, okay, it will redefine a number for each node in the entire course or pathway. So this would be expressed as the number of nodes, okay, squared. So it would just be for each entry, you would have all the nodes defined again. All right, the next entry, you would have another set of all the nodes defined again. So that's what we see here. Okay, so there's 11 nodes, that's 0b in hex. So in here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So these are being defined for the first entry, but they indicate each property for each node. Okay, so it's node count squared. So the problem with that is you end up with a n-to-n problem, which is that the more nodes you have, the exponentially more space it gets written, more data is consumed. So this is, to me, really silly what they've done here. Let's walk through what it's saying to us. So let's start with the first data set for the first node. So it's saying 0, so we're going to use different colors. Kind of running out of colors here. We'll just delete this and we'll start over fresh. And we'll start with red. All right, so it's saying for the first we have 0, and then the rest of them are all ones. 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. So what this is telling us is that these, okay, they're all parented to 1. They're children to 1. So that if we were sitting at 1, these would be downstream, and this would be upstream. Okay. Also as well in here, we'll have the number 0, and what's odd about that is if it defines itself, then it seems to be relevant data. Okay, so if we look at 10, is it equal to 1? No. Is 8 equal to 1? No. Is 9 equal to 1? No. And you go through that, and in this case, you'll find that 1 equals 1. Awesome. 0 equals 0. Awesome. And so what this means is that if we're sitting at 0, 1 is our child. All right, and that's how that works. And it's really bizarre how they've set this up. So go through another prime example here, which is one of these junctions, and we'll see how that's practically written. So we're going to start with 7. So in the list here, we have 0, 1, 2, 3, 4, 5, 6, and 7. So that would be that in the aqua or crayon color, or crayon. So it just says 5, 5, 5, 5, 5, 5, 5, which is going 1, 2, I should have counted it, 1, 2, 3, 4, 5, 6, 7. So just write that in here, 1, 2, 3, 4, 5, 6, 7. All right. So do these equal? No. These equal? No. These equal? No. These equal? No. 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 So this is telling us that these pathways are all connected to 5. Because does 5 equal 5? Oh, hell yeah, it does. So that is going to be a child. All right, we'll continue on. The next number is 7. Right now we would be at the 7 position. Okay, so that would be 7 here. So is 7 equal to 7? Yes, it is. I don't know why it defines itself, actually. It's kind of weird. But anyway, then we have 8, 8, and A, so that would be over here. 8, 8, and A is 10. Okay, so does this match? Yes, it does. Does this match? Yes, it does. Does this match or equal to itself? No. Okay, so what this is telling us is that 8 is connected to 8, and then these are all good, so that means that they're childs. So that means that these link to 7, this is linking to 7, and this is linking to 7. And 7 is 7 because we know its position in the table, so it's just connected to itself. So the purpose for this data isn't really clear. I'd imagine if an enemy had spawned somewhere along this pathway and you wanted the enemy to get to this position, you could say, oh, this pathway is connected to 5, which is a child of 7, so we should walk all the way around till we get to 5 and then decide to go to 7. I don't really know. The way the data is written is actually bizarre and very wasteful in my opinion. I think it could have been just written with some tables, but anyway, that's the way that it's done. So to read and write the data back seems to be pretty simple, as we do understand everything and how it works in the file. All right, so now let's do some visualization. So I'm going to draw that with the program that I wrote. Where did I put it? Here it is. Bam. Oh, that's the wrong file. My bad. That's the file we were looking at, so let's look at that one. And this is what we get. It looks a little bit different. This is basically the file. I'm just going to flip this so that it makes sense. All right, it's a little bit different than our picture, but this is what it is. Just going to clear this up so we can see that our move this a little over here. There we go. So we can share a shape here. This is 0. It goes to 1, 2, 3, 4, 5, 6, then branches back down, 7, 10, 8, 9. Okay, so that's what we seen in the game. That's what we get plotted out. And we should be able to modify these, but I'll talk about the challenges I'm facing at the moment. At the moment, how I'm drawing this is I'm creating a node, and then I'm creating a line segment across the node. What I found is that I typically get a duplicate. Well, in all cases I get a duplicate because the way the file is written, it tells us that from here we need to draw a node to here. And then when we get to this one, it'll say, oh, we need to draw a line from here to here. So what I need to do is I need to pre-process and look for a duplicated line and just not draw it. And so I'm only drawing what I want to draw. But then it comes into play, well, how do we describe the parenting? Because that's important, because right now this is just a random line. They are technically not connected. And so that's the challenge. I could have done this another way, which is just doing a pure line segment. So in 3ds Max we can create a line segment like this, and we can draw any kind of bizarre shape we want. Of course we don't want the curves, but yeah, and you can get away with that and you get the shape. But again, of course, we have to do the pre-processing, so we don't go from here to here and then back, and then and we get that redundancy. So we only get a single drawn line at a time. But I found that that's like, I don't know, I just felt like it wasn't as visual as I wanted it to be. You have to come into here, and you would have to splice in a line and stuff like that. And I felt that wasn't something suitable that I wanted. Another thing I considered is the protractor itself. So if we go into the helper, we have a thing called a protractor just here. And what's nice about the protractors is you can draw connections to them. So we can go here and here. And what's cool about this is, actually, you know what, let's not do that way. Let's do this instead. We'll just do the single connection, so it's not blue and green. All right, and so now we can see these segments. And if we want to tether in another one, it's relatively easy. So we just create another one. I go, oh, I want to connect here. And we can create these segments that way. And the nice thing about that is they're movable. All right, and you can still visualize their connections. So I really like that idea. However, the helper class that we get for the protractor is surprisingly barren. So if we bring up the protractor, protractor, all right. In the help me, you don't have any access to any of the control of the object, which is surprising. I looked it up on the internet. Apparently, you can extend the abilities of the protractor by using a custom scripted plugin. So this is a code snippet that somebody posted. They call it protractor, and it shows you how you can access the angles by creating a custom parameter. But right now I'm having a hard time understanding how we can create a custom variable for the object selection. Because if I can sort that out, then I can achieve this. I think this is a really cool idea to have these sort of helpers represent the RTP data. So anyway, that's where I'm at right now. Some of the challenges I'm facing. Right now with the format, I've been able to read it and write it. It's just a matter of bringing it into 3ds Max in a more practical manner. So we can visualize it very well, and then of course we can write that to the file back, no problem. And that I think that worked pretty well. All right, thanks for watching, and take care.